All right, I'm going to do that hypothesis test that we just did using the critical value method showing all 5 steps about promotional status versus overseas assignment. To do this on your calculator using the p-value method is pretty simple. First of all, you have to enter in the table into memory in the form of a matrix. 2 rows by 2 columns. To do that, you hit your matrix button, MATRX. Go over to edit. Notice our cursor is sitting on matrix name A. We're going to edit. Hit enter to edit. You need to specify how many rows by how many columns your matrix has, or table has. We have 2 rows by 2 columns, so I'm going to type in 2. Hit your right arrow key, and then type in 2 columns. Hit enter. Now, ladies and gentlemen, we're going to type in the observed frequencies that are in our table. So the 1-1 observed frequency is 16. Hit enter. The 1-2 observed frequency is 24. Hit enter. The 2-1 observed frequency is 22 from our table here, 22. So we type that in right here. Hit enter. And the 2-2 observed frequency is 38 from our table. So we type in 38. Now that we have this matrix entered into memory, we get out of the matrix editing mode by hitting second mode to quit. So second mode quits. Now we're ready to perform the chi-square test of independence. To do so is pretty simple. Just hit your stat button, go over to tests, scroll down, keep scrolling down till you run into the chi-square test. Hit enter. Notice your observed frequencies will be thrown into matrix A, and that's where we put them, and our expected frequencies will also be computed behind the scenes by the calculator when performing this test, and they'll be automatically put into matrix B. This is going on to calculate. Hit enter, and we're ready to conduct the chi-square test of independence. There we go. Notice our p-value, as predicted, is very large, 0.736, about 74% chance of committing a type 1 error if indeed we did reject the null hypothesis. So this p-value is way too large. It's much larger than our level of significance 5% that we were testing at, and therefore we cannot reject the null hypothesis. And that's the same conclusion we gathered by doing the test the long way using all 5 steps, the critical value method. Therefore, we would conclude that promotional status and overseas assignment status are independent categorical variables. So they're independent of each other. I would like to go over a problem in our textbook, another chi-square test of independence problem. This problem is on page 539 in your textbook. It is problem number 9 on page 539. I'm going to have to zoom out a little bit here. All right, so again, this is problem number 9. On page 539, and it reads this way: Are health and happiness related? The following data represent the level of happiness and the level of health for a random sample of individuals from the General Social Survey. Notice we have 3 rows: very happy, pretty happy, and not too happy. And then we have our other categorical variable, which is the health variable: excellent health, good health, fair health, or poor health. So, ladies and gentlemen, we're going to test the hypotheses that say, the null hypothesis will say that happiness and health are independent of each other, versus the alternative hypothesis statement would say happiness and health are dependent upon one another. To conduct this chi-square test of independence, to test these hypotheses, we would have to enter in this 3 by 4. Notice there's 3 rows by 4 column table. So a 3 by 4 matrix into memory. So we'll have to type in the 3 by 4 matrix into memory here. Tell you what, I'm going to come back to this problem in 1 second here. There's something that I wanted to tell you when we conducted the chi-square test of independence with the last problem involving the promotional status versus the overseas assignment status. One thing that I wanted to point out is that when we conducted a chi-square test of independence, our observed frequencies were in matrix A, and our expected frequencies were put in matrix B. To view your expected frequencies, you would have to go back to your matrix mode. So you would hit your matrix button, M-A-T-R-X, right here. And notice, ladies and gentlemen, that not only do we see our matrix A, which was populated by our observed frequencies that we put into the calculator, but notice matrix B was also created and populated with the expected frequencies. And to look at the expected frequencies in matrix B, all you have to do is stay on names, hit your down arrow key to go down to matrix name B, and then hit enter. And then hit enter again, and you can now see the expected frequencies which are in matrix B. Notice these are the same expected frequencies that we computed with the first example that I showed you and walked through. The 1-1 expected frequency was 15.2, 24.8 is the 1-2 expected frequency, the 2-1 expected frequency is 22.8, and the 2-2 expected frequency is 37.2. So we can see these expected frequencies are automatically computed when conducting a chi-square test of independence, and that's something that we don't have to do manually like we did when doing the problem using the critical value method. Okay, back to this problem here, number 9 on page 539 here. Ladies and gentlemen, we have to enter in the memory into a matrix, a 3 row by 4 column matrix, 3 rows by 4 columns. And so therefore we're going to have 3 times 4 or 12 observed frequencies to enter in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here we go. We first of all have to populate a 3 by 4 matrix. So let's go on our calculator, hit our matrix button, M-A-T-R-X, go over to edit, hitting your right arrow key, over to edit. Oh, gosh darn it. Darn calculator, I think it died again. Go over to edit, hit enter, and now we're going to have to type in 3 rows, enter, by 4 columns, enter. Now we'll type in all our observed frequencies. So I'm just going to follow along in the table here, and we're going to go across and type in our observed frequencies. So 271, enter, 261, enter, 82, enter, 20, row 2, 247, 567, enter, 231, 53, now row 3, 33, 103, 92, and 36. Now that we have our 3 by 4 matrix entered into memory, we get out of this by hitting second mode to quit. Now we're ready to conduct the chi-square test of independence. Go over to, hit your stat button rather, go over to test, scroll down, and grab the chi-square test function. Hit enter. Notice our observed frequencies will be in matrix A, and the expected frequencies, the 12 expected frequencies, will automatically be computed behind the scenes and put into matrix B. Let's go down to calculate. Hit enter, and here's the test. Notice we have a p-value that is extremely small, 1.719 times 10 to the negative 36 power. So for all practical purposes, ladies and gentlemen, this p-value is extremely small, and therefore we will reject the null hypothesis. Notice our test statistic is 182.17. That's your test statistic. If you were to conduct a test using the critical value method, you would crank that out using the formula that was mentioned in the previous or the initial problem. So because our p-value is very small, we reject the null, and therefore we would conclude that happiness and health are statistically dependent categorical variables, because we're going to go with the alternative hypothesis in rejecting the null hypothesis and saying that happiness and health are dependent upon each other. There's some sort of relationship between these variables here. And if we were testing at 5%, we would only have a 5% chance of committing a type 1 error in rejecting the null hypothesis that, may be true. Because our p-value is so very small, this is an extremely conclusive test. I would have no doubt whatsoever in my mind to reject the null hypothesis. So again, because the p-value is so small, reject the null, and therefore these two variables, happiness and health, are dependent upon each other. So that shows you how to use the calculator in doing the chi-square test of independence, the p-value method. It's pretty simple. First, you enter your table into a matrix into memory. Then you go to stat, test, chi-square test function, and conduct a chi-square test of independence.